Hey guys, Mrs. Dan's here. So we are on lesson 3 now. Today we will be dividing with monomials. I have to remind you that I don't typically like just following a bunch of rules. I like to do what makes sense. So you already know what an exponent means, right? It tells you how many times to write out the base as a factor. And back in like fifth grade, sixth grade, you knew how to simplify fractions. So as long as you can remember that, you could do today's lesson. I will be providing this getting ready document for you to refer back to if you want to look at it on Google Classroom. The objectives here, it tells us that we're doing a do now. It tells us our plan for the day. I want to go over the do now, some of the development together, and then you're going to practice on your own. And that your homework is from the textbook, page 412, numbers 1 through 10. And I have left space in your workbook on page 13 for you to do the work. So if you didn't write the objective down, please do so. And then do the do now without me. So why don't you hit pause? So welcome back. So it's asking us to find the length of the rectangle, given that the width is 2x, and that's diagrammed here on our picture, and the area is 8x to the fourth. So remember that area is length times width. So we just have to think 2x times what gives me an 8x to the fourth. So I definitely know I need a 4, right? Because 2 times 4 gives me 8. And then I have to figure out how to get this x to the fourth. So if I already have an x, I need an x to the third here in order for the area of the rectangle to be 8x to the fourth. Then we had to simplify this. Remember, when I simplify, I definitely like to expand it. So these parentheses need to be written out 3 times. So I'm going to do it over here. And it's being multiplied by a negative 2xy. Now you could expand again, or you can think about what the expansion would look like. I see that I have 3 times 3 times 3 times negative 2. So 3 times 3 is 9. 9 times 3 is 27. And 27 times negative 2 is a negative 54. Next, I'm going to look at my x's, and like I count out loud, I count right here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have x to the 10th power. And with the y's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Y to the 16th power. So the answer is negative 54, x to the 10th, y to the 6th. Number 3, to simplify this, I can divide top and bottom by 100, right? That's how we originally learned how to simplify fractions. So I get 1 over 100. And 32 over 4, I could divide top and bottom by 4. So I get 8 over 1, which is the same thing as 8. So you really do need to know how to simplify fractions. You really do need to know how to expand with exponents. Number 5 might not seem related maybe to what we've been doing, because I'm asking you to fill in a table. And this is really important. I want you to look at the pattern from above to fill in these bottom few. I think up here, it's pretty easy. 2 times 2 times 2 times 2 is definitely 16. 2 times 2 times 2 is 8. 2 times 2 is 4. Just a 2 is a 2. And then this stuff down here, people mess up. So that's why I asked you to look at the pattern. Do you notice it's 8, and then it's 4, and then it's 2? Isn't it being cut in half each time? So if that pattern exists up here, the pattern must continue. That's the nice thing about math. Math is discovered from patterns that are created. So over here, there's a pattern. I keep on decreasing the exponent by 1, and I don't break the pattern. Therefore, on this right side, I can't break the pattern. It keeps on taking half of it. So I guess this is a 1. And then I guess this is half. And I guess this is a quarter. And I guess this is a an eighth. I almost said a 16th. So math is really discovered. It's not made up. And you can see that I divided by 2 each time up here. And that's why I continue to divide by 2. 1 divided by 2 is a half. A half divided by 2 is a fourth. A fourth divided by 2 is an eighth. And then once we follow that pattern, we could notice something that's pretty significant to notice. I notice that this is an 8, while this is 1/8. And then I notice this is a fourth, while this is 1/4. And I notice that this is a 2, while this is 1/2. So they're reciprocals of each other. And take a look at what this problem was. That was 2 to the third. And look at this one. It's 2 to the negative third. Huh. So you mean that 2 to the negative third really is the reciprocal of 2 to the third. Does that always happen? Well, this is 2 to the second, and this is 2 to the negative second, and this is a 4, while this is a 1/4. Interesting, right? When your exponent is negative, it like flips it around. It's just the reciprocal of the positive. And that actually is the true definition of negative exponents. Negative exponents always are the reciprocal of the positive. So if I asked you what is 3 to the negative second power, your first thought should be, well, I wonder what 3 to the second is. 3 to the second power is a 9, so 3 to the negative second must be a 1/9. Do you notice that negative exponents never give a negative answer? Negative exponents are not negative numbers. Negative exponents are reciprocals of something with a positive exponent. Let's write that down. And don't forget this, okay? Don't forget this. Make this stick in your mind. Okay, negative exponents lots of times look like fractions since they're the reciprocal of the positive exponent. And now here with the development, I'm going to jump around. You know I don't like teach each problem in order. There's so many problems here. I want to hit the ones that will teach you the skill I need you to know, and then I'm going to want you to try some on your own. So when I do number 1, again, I like to expand. So the numerator is x times x times x times x times x. And the denominator is x times x times x. So I just want to simplify this like how we simplify fractions. I'm going to make a new problem up here actually. If I gave you 2 times 2 times 2 over 2 times 2, I would hope that you would know that 2 over 2 simplifies to be 1. So I can change this to 1 over 1. And then this 2 over 2 simplifies to be 1 over 1. So we can just simplify fractions like we used to do in elementary school. And in the numerator, now I have 1 times 1 times 2, therefore I have a 2. And in the denominator, I have 1 times 1, which is a 1. And you know that the best way of writing this is with 2. So if I could do that with numbers, I should be able to do it with variables because remember a variable represents a number. So if 2 over 2 is 1 over 1, what's 5 over 5? Sure, it's 1 over 1. What's like negative 3 over negative 3? Yep, you're right. It's 1 over 1. So what's x over x? I guess it's 1 over 1, right? That x is some number. Maybe x is a 2, so therefore we would say 2 over 2. So anytime you have a number over itself, it always simplifies to be 1 over 1, or you could even just call it 1. So right here, this is 1 over 1. And right here, this is 1 over 1. So if we expand the numerator and expand the denominator and then simplify fractions like we did when we were younger, you can figure out the answer to this problem. So the numerator is 1 times 1 times 1 times x, which really is just x squared. And the denominator is 1 times 1 times 1, which is 1. You don't need a 1 in the denominator. I'm going to say this answer is x squared. Some people do notice a trick, and that's what I call it. It's a trick to go from the original question to here, but I'm not even going to say that out loud. You know me. I don't like say these crazy rules. I actually expand and I think about why the answer makes sense. X to the fifth over x to the third is x to the second because of the expansion and the simplification. So let's take a look at number 2. If I expand, that's the numerator and the denominator. And then if I simplify, this is 1 over 1, and this is 1 over 1. So my answer turns out to be x to the 8th. And yes, I know you're thinking to yourself, the silly rule. Looks like we're subtracting the exponents. But I'm just going to keep on expanding and simplifying. So I hear that I actually said something in the do now and wrote it differently. I said that this was a 16 and I wrote only a 6. So I just want to clear that up. It's definitely 16, right? I counted all of these y's. 5, 10, 15, 16. That's definitely 16 y's. So you can thank Amber Dans for that one. So the next number I want to do is 3. And if I expand this, I get x times x times x times x over x times x times x times x times x times x times x. And we're going to simplify. This is 1 over 1 and 1 over 1 and 1 over 1 and 1 over 1. So my numerator, 1 times 1 times 1 times 1 is a 1, while my denominator, 1 times 1 times 1 times 1 times x times x times x is x to the third. So do you notice that this one looks like a fraction where number 1 and 2, since the 1 was in the denominator, it actually doesn't look like a fraction? So I guess we are going to kind of talk about that crazy rule for a second because some of you might want to follow it. That for number 1, it looks like I can keep the base of x and subtract the exponents, and I get a 2. And for number 2, it looks like I could keep the base of x and subtract the exponents, and I get an 8. But does that trick really work here for number 3 then? Well, if we discover a rule, the rule is always supposed to work. So if it's true that you can subtract the exponents, it means that it has to work in number 3. So let's think about number 3 for a second. If I keep the base of x, if I subtract the exponents, 4 minus 7 is negative 3. Oh, I think we just learned something in our do now, didn't we, about negative exponents? I remember negative exponents are the reciprocal of the positive, right? So if I reciprocate this, don't I get 1 over x to the third? So x to the negative third is the same thing as 1 over x to the third. And look at what we said our answer was when we expanded it. So really the expansion works. Really this crazy trick works as long as you remember that negative exponents are the reciprocal of the positive. What we say is that a negative exponent is never completely simplified. So you'd never be able to write your answer as x to the negative third. I wouldn't give you credit on a test or a quiz for it. So if you use that crazy trick, which you'll see Mrs. Dan's like never uses because I hate negative exponents. But if you use a crazy trick and you get a negative exponent, you then have to do one more step and rewrite it as a positive exponent by using its reciprocal. So I don't like using negative exponents. And I don't always like expanding. Like, let's look at number 4. I don't feel like writing 2x's in the top and 10x's in the bottom, but I can imagine myself doing so. And if I did it, wouldn't we be crossing off some x's from top and bottom? Isn't there x's in common? I'm hoping you're saying yes. And then if I ask you how many x's are in common with the numerator and the denominator, I'm hoping you're telling me 2, right? There was only 2 x's in the top. So there's only 2 x's in common. So sometimes with my original question here, I say, oh yeah, if I get rid of 2 of these x's, it's a 1. And if I get rid of 2 of these x's, I'm left with x to the 8th. So I simplify my fraction to get my answer, and I avoid negative exponents. So that's how I tend to do things. Our final answer is 1 over x to the 8th, whether you use the silly trick and get a negative exponent and then rewrite it, or if you just simplify. On number 5, if I expanded it, because there's not too many things to write down, I'm hoping you realize the answer is a 1. Right? Y over y is 1 over 1. Y over y is 1 over 1. And y over y is 1 over 1, which leaves me with a 1. You should have known that right from the very beginning, because y to the third over y to the third, it's the same number divided by itself. Whatever y to the third is, if it's in the numerator and in the denominator, of course it simplifies to be 1. Any number divided by itself is 1. So number 6, any number divided by itself is 1. Right? You can just write down the answer if you're really getting this. What do I want to do next? I guess I'm doing number 7. Instead of expanding all this, I'm going to do my simplification right here on the problem. I'm just going to make it a little bigger so that my work isn't so squishy. If there's an x to the third in the numerator and an x to the 7th in the denominator, numerator and denominator has x to the third in common. If I get rid of these 3 x's, I'm left with 1. And if I get rid of 3 from here, I'm left with x to the 4th power. Now in the numerator, there's a y to the 2nd, and in the denominator, y to the 2nd. Oh, that's the same number divided by itself. That's going to be a 1 over 1. And with my z's, I know that z to the 2nd is what's in common, right? I have 10 z's being multiplied in the top and only 2 z's in the bottom. So what's in common? Only 2 of the z's being multiplied. So this is a 1, which means I'm left with z to the 8th in the numerator. So sometimes things are left in the numerator, sometimes things are left in the denominator. The way I think about it is wherever I have more of the factors, that's where it's left. So in my numerator, 1 times 1 times z to the 8th, I'm left with z to the 8th in the numerator. And x to the 4th times 1, I'm left with x to the 4th in the denominator. And this is my answer. I can't simplify this any further because z's are not like x's. They're not common factors that can be simplified. So really, wherever you have more of something, that's where it's going to be left. I'm going to skip for a second. I'm going to skip to some of these with numbers. So I'm on this next page. 5 to the 4th over 5. It's like a 5 to the 1st power, right? I have more factors of 5 in the numerator than I do in the denominator. So whatever I'm left with when I simplify will be left in the numerator. I can simplify 1 5 from both top and bottom. And if you can't see it that way, you can write these out. And really just there's 1 5 in common top and bottom. Therefore, I'm left with 5 to the 3rd power. I had more factors of 5 in the numerator. Makes sense that I have 5 to the 3rd in the numerator. You hear me calling it the numerator. There is a denominator here. It's 1. We just tend not to write it. Right? But on number 2, do you see that there's more factors of 3 in the denominator? This answer is going to turn out to be 1 over 3 squared. And if you can't see it as quickly as I can, please expand it. The numerator has 3. The denominator has 3 times 3 times 3. So there's a common factor of 3 in top and bottom, and I'm definitely left with 1 in the numerator times 1 times 3 times 3, which is just a 3 squared in the denominator. If you wanted to follow the crazy rule, we could keep the 3. And remember, this is an exponent of 1. We can subtract the exponents. 1 minus 3 is -2. That's not good enough, though. I have to rewrite it as the reciprocal of the positive. So I tend to try and stay away from those negative exponents. I prefer to just simplify and get my answer. But both ways are correct. I'm going back to this other page. I wanted to point out, like number 8, you can say you're done. There's nothing in common. I can't do anything with that. Wanted to look at number 9. They give it to me as a negative exponent, so I have to deal with it. You know, I said I try and stay away from it. I guess I can't in this case. I have to rewrite this as 1 over x squared. The negative exponent is always the reciprocal of the positive. So this is where we get tricked up now. Don't forget that the exponent only belongs to what's directly in front of it. The exponent of -2 only belongs to the y. Maybe you even want to just circle it. So this x to the 4th, that's a positive exponent. There's nothing wrong with it. But this y to the -2nd power has to be rewritten as the reciprocal of the positive exponent. So now it looks like I have x to the 4th times 1 over y to the 2nd. I could put a 1 in the denominator here to make it look like a fraction times a fraction. And when I multiply the numerators, I get x to the 4th. And when I multiply the denominators, I get y to the 2nd. There are no common factors, so that's your answer. So this is where things maybe start to get tricky, so you have to be really careful. Number 11 and number 12 look similar, but they're two different questions. Okay, this exponent of -2 only belongs to the x when we're doing number 11, where this exponent of -2 belongs to the whole parenthesis when we're doing number 12. So if I rewrite number 11, there's nothing wrong with the 3, and it's being multiplied by 1 over x squared because I have to rewrite my negative exponents as positive exponents. I could put a multiplication sign here to make it look a little nicer. I could even put a 1 underneath this 3, and I can say my answer is 3 over x squared. Now when we do number 12, the whole parenthesis is to the negative power. So I have to do the reciprocal of the whole parenthesis. This turns out to be 1 over, in parentheses, 3x to the 2nd power. Okay, so notice that difference. The whole parenthesis gets reciprocated, where in number 11, I only had to worry about the reciprocal of that x to the -2nd. Now I can take number 12 a step further, by the way, and I should take it a step further. I should write this as 1 over 3x times 3x, right? Those parentheses have to be written out twice, which means I can write this as 1 over 3 times 3 is 9, and x times x is x squared. This is the final answer that I'd want you to write. Let's take a look. Number 13 tricks people up sometimes because there's a negative exponent, but now it's in the denominator. Now there's like an easier way of thinking of this. There's a difficult way and an easy way. I guess maybe I'll talk about both ways because your first thought might be the difficult way. You might be thinking that, okay, this is x to the 5th, nothing wrong with it. And then this denominator I have to write as 1 over y to the 5th, right? Because it has a negative exponent. But holy cow, now I have a fraction and a fraction, right? Fractions in fractions sure don't look nice. They're actually not considered simplified. And I'm really doing this like the long way. I would rewrite this. You know that a fraction bar, like let's talk about that fraction bar. Let me make it a different color so you know which one I'm talking about. This fraction bar really represents like division. And do you remember with division, you like learned how to keep, change, flip, right? You always like flipped when you multiplied. So if I were to rewrite this using a division sign like that, in 6th grade, I think it was, you would say keep, change, and flip. So do you see the answer really turns out to be x to the 5th times y to the 5th. And that's your final answer. Now I told you I was going to do it the difficult way first. I don't do it this way, but it might be the first way you kind of thought of. So that's why I wanted to do it. I want to redo this a different way. X to the 5th over y to the negative 5th. The way that I think about this is by always wanting to fix my negative exponents right away, and I circle them like what I was circling up before. And we know that a negative exponent is a reciprocal of the positive. So if this negative exponent is in the denominator, when I reciprocate it, I guess it has to come to the numerator and become positive. So a lot of times what I do is I say, oh, I'm going to cross off the negative exponent and move its location so that I can make it a positive exponent. The only reason why I want to move its location is because I really did the reciprocal. Do you see I just got the answer right away now? It's x to the 5th, y to the 5th. So let's try it again with number 14. I would say this needs to get fixed. I don't want it here. I want it here with a positive exponent. Anytime you move its location, the exponent has to change to positive. We never move a positive exponent. Those are good. Never change the location of a positive exponent. It's only the negative exponents we have to worry about. So now in the numerator, I have x to the 5th times x to the 3rd. There's like a 1 in the denominator, but we really don't need to write it, right? What do you need to write ones in denominators for? And now x to the 5th times x to the 3rd is x to the 8th. Weird, right? That x to the 5th over x to the negative 3rd completely simplifies to x to the 8th. So I like to fix my negative exponents. It's kind of like the words that I use. I fix them. It's not really math terminology. It's like the way that I think about it to make things easier for myself. So let's see. I think I want to do some of these because there's some coefficients here. Which one would I like to do? Let's go right to like number 14 here. So remember, I like to think of this as a fraction that can be simplified. So I first look at the 14 over 6. There's a 2 in common. 2 goes into 14 7 times. 2 goes into 6 3 times. So that's that simplification. Now I look at my x's, and I see that there's an x to the 4th in the numerator and an x to the 5th in the denominator. So I say to myself, there's x to the 4th in common. I can get rid of x to the 4th in the numerator, make it 1, and in the denominator I'd be left with an x to the 1st power. And then with the y's, if I have a y to the 7th in the numerator and a y to the 4th in the denominator, the most amount of y's in common is y to the 4th. This becomes a 1. And if I'm simplifying out a y to the 4th, then this must be left with a y to the 3rd. Now, if this way is confusing you, please expand it. So if I were to expand it, I would write down 14 times x times x times x times x times y 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 over 6 times x times x times x times x times x times y times y times y times y. If you expand it, you really can't go wrong. Right? Some people say, I don't want to do all that work, but you know what? I'd rather do a lot of work and get it right than do no work and get it wrong. So again, you have to know how to simplify 14 over 6. That's just 5th grade stuff. So there's a 2 in common. And then this x simplifies with that x. This and this simplify. This and this simplify. And this simplify. Do you see there's an x left in the bottom? That's what I had over here. And then with the y's, a y simplifies with a y, another y simplifies with y with y with y. Just so you know, when you cross them out, they're really turning to ones and not going away. And look at, I have y times y in the numerator. Oh, that's what I had over here, y to the third. So what's the final answer? 7y to the third in the numerator and 3x in the denominator. That's your answer. So you are pretty much guaranteed to get the right answer if you expand it. You could make mistakes if you're doing some work in your head. The more you practice this, though, the less expanding you'll have to do. So really, you might want to expand for the rest of today. So I'm going to say I'm done. 31-minute video. And I think I'm going to put the rest of these answers posted in Google Classroom, the rest of the classwork that is, so that if you wanted to do more, you can check and see if you did it right. And then your homework, remember, is from the textbook. So do your textbook page and hand it in. And I'll talk to you soon. See ya. Bye.